Okay, folks, I'm going to go through the second set of problems here, starting with number 8, pretty quickly and pretty quietly, because it's kind of late at night, but this is a very good time to be working, actually. Now, they're asking for the concentration here, and they give you a volume and a concentration, and they give you another volume. The fact that there are two different volumes or two different concentrations, in this case there are two different volumes, means that you're going to use the dilution formula, which is in the textbook. M1 is the first molarity, V1 is the first volume, M2 is the molarity that you end with, V2 is the volume that you end with. Here it says concentration of the final solution. That means we're talking about the molarity that you end with. That's what they want to know. This is what they started with. This is the volume 1. This is the molarity 1. And the total volume at the end, that's the volume 2. I'm going to use some algebra here. Algebra is not necessary, but it's just convenient. So I want M2. Here's M2. I'm going to solve for it by dividing both sides by V2. These cancel. I got M2 alone. So I'm going to start plugging stuff in. The units can be molar and they can be milliliters, or they can be molar and liters. It doesn't matter as long as you're using milliliters throughout the problem or you're using liters throughout the problem. I choose to use milliliters today, so I'm going to change this number also to milliliters. That's going to be times 1,000, so that's 1,300 milliliters. Now I'm going to plug stuff in. 6, that was the M1, molar. Notice I still write the units even though I'm using a formula here. V1, 33 milliliters, divided by V2, 1,300 milliliters. The reason why I wrote the units is because I can cancel out the milliliters and see that I get molar at the end. And is that what I wanted? Yes, they want the concentration, so that's what I wanted. That's why I used the units here. 6 times 33 divided by 1,300. Ask the calculator for that. 6 times 33 divided by 1,300. I got 0.152. But there are only two significant figures here, so it's 0.15. The units are molar. That's the answer, folks. There's an example of this worked out for you in the textbook also. It's somewhere in there, chapter 4. If you look up the word dilution, find where it occurs in chapter 4, you'll see the example there. Here we have another dilution problem. He diluted it. So here, instead of giving me molar and 2 volumes, he gives me a bunch of volumes and grams. So I'm going to have to convert these grams to moles because I need to get molar. If I want to use the dilution formula, I need to have molar. So he's got 250 milliliters. The stock solution is the first solution that they work with, and that's this one, 1.21 grams, 250 milliliters. Remember that molar is moles per liter. So I'm going to change this to moles and divide it by this many liters. So change this to liters. Changing this to liters is 0.250 liters. I just moved the dot over 3 times. Of course, in the previous video I showed you the conversion between milliliters and liters the long way, but I assume that you're okay with that. So you can do that yourself if necessary, or you can just do like me and move the dot if you understand that process. Either way is perfectly fine. That's how many liters we've got. Now I'm going to use change this to moles. So I've got 1.21 grams of iron chloride. Now I can put this over this many liters if I want, or I could do it separately. I could find the moles and then in a separate calculation divide the moles by the liters. Either way is fine. This stuff was made into a 250 milliliter stock solution. So I choose to do it all in one go. This stuff is a 0.25 liter solution. That's why I could put it into a fraction like that, because that's what it is. It's made into a 0.25 liter solution. Now I'm going to get rid of the grams. I want moles per liter, moles over liters. So FeCl3, FeCl3, 162.2. You will do this on the periodic table, which will be provided for you on the quiz. That's 1 mole of FeCl2, Cl3. Grams cancel. Woo! And I've got 1.21 divided by 0.25 divided by 162.2. That was 1.21 divided by what? Forgot. 0.25. 0.25 divided by 162.2. Oops. There we are. Yes, 162.2. So the answer is 0.0298. Oops. That's 0.0298 molar FeCl3 solution. Is that my final answer? No, because he took 1 milliliter, I'll do this in green, he took 1 milliliter of that and diluted it again. So he took 1 milliliter of this solution, so this is M1. The V1 is he took 1 milliliter of it, okay? And the M2 is what I want. And the V2, he diluted it with water to give this much of a final solution. So that's V2, 125 milliliters. Why am I going to look for M2? It's because when I look for M2, I will find the molarity, and from the molarity I can get moles, and from the moles I can get grams of Cl minus. This is going to be a little bit involved here, so hang on. I want M2, so the formula is M1V1 equals M2V2. I want M2. This is just like in the previous problem. I divide both sides by V2. So plugging stuff in now. M1 was this, 0.0298 molar. V1 was this, 1 milliliter. V2 was this 125 milliliters. So that's going to be M2. That's 0.0298 divided by 125. So this divided by 125, that is 2.39 times 10 to the negative fourth molar. 2.39 times 10 to the negative fourth. So the milliliters cancel. 2.39 times 10 to the negative fourth molar. What is this? FeCl3 still? Yes, it's the same thing. FeCl3. Okay, now they want grams of chloride ions. So I'm going to have to convert this into moles of FeCl3, and then convert that into moles of chloride ions, and then convert that into grams of chloride ions. And I can do it all in one go. So let me show you what I mean by that. 2.39 times 10 to the negative fourth. This is moles of FeCl3 solution. FeCl3 in 1 liter of solution. SOL apostrophe N. That's my abbreviation for solution here. I know it's in 1 liter because that's the meaning of molarity. Molar means moles per liter. Now I know how many liters I've got of this. I've got the final volume at 125 milliliters. 125 milliliters of the final solution. So that's 0.125 liters. So that's going to cancel the liters. Now we have moles. But I don't want to stop at moles. Liters are canceled. I want actually moles of chloride. So for every 1 mole of FeCl3, moles of FeCl3 are canceling here. For every 1 mole of FeCl3, how many moles of Cl are there? Well, in one of these FeCl3, there are 3 Cls. That's 3 moles of Cl minus. Now I've got moles Cl, but I need to change this to grams. So I know that in 1 mole of Cl minus, from the periodic table, there are 35.45 grams of Cl minus. The moles of Cl minus will cancel out. Moles are canceled, liters are canceled, moles are canceled, moles are canceled. Grams are the only thing that are not canceled. That means the answer is going to be in grams, which is what I want. How many grams? So I go 2.39 times 10 to the minus 4 times 0.125 times 3 times 35.45. This times 0.125 times 3 times 35.45. I've got an answer of 0.00317. So I've got 0.00317 grams of chloride ions. Let's see if that makes any sense. I only started with 1 gram, and then I diluted it in water, and then I took a very small amount, that's like just a few drops of that water, and I diluted that into more water to get this large volume. So yeah, it makes sense that I'll have a very small amount of this chloride ion at the end if I started with this amount, just more than a gram of the iron 3 chloride. So that was a bit involved, wasn't it? Let's make some clean space here. Let's clean this workspace up a little bit. I think it's always important to have some clear workspace. I'm a messy guy, but having some clear workspace is really important for me when I'm trying to figure something out. Okay, how many grams of sodium chloride are formed when this reacts? Okay, so here we're going to convert from a solution with volume and a concentration into grams of something else. So I'm going to have to use the periodic table. So I'm converting NaOH. Oh, okay. There's a typo in this problem. I'm sorry about that. The typo is this NaOH. This should be NaOCl. Okay. This should be a gas. Well, no. This shouldn't be a gas, actually. This should be NH3. This equation is what you get when you mix bleach with ammonia. This is why you shouldn't mix household chemicals, because this is not the only dangerous chemical reaction that results when you mix household chemicals. If you mix bleach with ammonia, which are both household chemicals, you can produce this stuff. This is chloramine. It's found in very dilute amounts in tap water, but when you produce this as a pure gas, it's very poisonous, and it will cause your nose some pain. So now that I have corrected typos, a few typos here, we can proceed. I apologize for the typos. Change color to black. So I have a certain amount of this stuff, and I have excess this, so I don't care about this. And I want to know how many grams of this are formed. So I need to find the moles of this stuff from this information. Remember that molar is moles per liter. So I can easily find moles. I'll put moles on top, so it's 0.0133 moles per 1 liter. That's what molar means. That's what the big M means. This is NaOH. Now, I want to remove the liters. I know this is 0.032 liters. 0.032 liters. You can do the conversion yourself on the page or on the piece of scratch paper if you like. And then liters cancel out and I get a certain number of moles. 0.013 0.0133 times, what was the other one? 0.032. 0.032. That's 4.26 times 10 to the minus 4th. This is only it's 4 significant figures here. I forgot the 2 zeros. There are only 3 significant figures here, so it's, forgot the answer already. 4.26 times 10 to the minus 4th. 4.26 times 10 to the minus 4th. What is this? This is units of moles of NaOH. NaOH. Right. Okay, so getting tired over here. So I'm going to start with that. 4.26 times 10 to the minus 4th moles of NaOH. Oh, I'm sorry. That's not NaOH. That's, really getting tired. This is NaOCl. I'm sorry. This is NaOCl. This is NaOCl. This is NaOCl. That's bleach, sodium hypochlorite, NaOCl. Right. Now, I know that 2 moles of NaOCl make 1 mole of NaCl. And I know that 1 mole of NaCl weighs 58.44 grams of NaCl. That's according to the periodic table. Moles of NaCl cancel. Moles of sodium hypochlorite bleach cancel. So I have grams of NaCl left over up here. That's what I want. So I do 4.26 times 10 to the minus 4th divided by 2 times 58.44. So that number divided by 2 times, times 58.44, I got 0.0124. Significant figures check, 0.0124. Okay, this is the lowest number of significant figures, that's 3. The answer is 0.0124 grams of NaCl. That's a very small amount. Does it make sense? Yes. This is much less than a cup, I think. Actually, I'm not sure. This is 10 times, a regular water bottle is about 400 milliliters, so this is like less than 10, yeah, this is way less than a cup. And this is much less than 1, so this is a very dilute solution. So I only have a very small amount of sodium hypochlorite, so I should get a very small amount of salt, of NaCl. That's good. Last problem in this video, but not the last problem on the practice quiz, is this. Which behaves as gas when dissolved in water? Oh, I'm sorry. Which behaves as base when dissolved in water? Now remember from my podcast and from the book, chapter 4, that bases give off OH minus, or they force water to give OH minus, and acids give H plus, or they force water to become H3O plus. Now who of these could be an acid? The guys who begin with H would be an acid right there. Begins with H right there. Begins with H. So those guys are acids. Now the guys who contain OH minus, if they dissolve in water, those OH minuses are going to be released. So these guys are the bases. Alright? That's how you do it. What if on the actual quiz they showed you NH3? Now this is a base because it does not begin with H. It does not give off H in water. This guy combines with water to, water is two H's and an O. Well, this guy will rip off one of the H's, stealing it, becoming NH4 plus instead of NH3. So it steals the H plus, actually. And what's left over is OH minus. See, this is the reason why NH3 is a base. In water, it causes the release of OH minus. So things that cause the release of OH minus are bases. There is another definition of base, but that is not relevant for our class. If you go on in chemistry, you will learn some other types of bases. That's it for this video. There will be 2 more videos, I believe, but I think I will post those tomorrow. Thank you. Bye.